thank you for the awesome introduction. I'm going to, as you already said, that's just a joint work of the Web Applications group and the Usable Security group. And I don't know how many people of you are familiar with the content security policy, so I'm going to give you a quick introduction over what's that supposed to be. So the content security policy is a mitigation for cross-site scripting. And cross-site scripting is today even one of the most prevalent vulnerabilities in the web. So we will just now go step by step through one cross-site scripting attack, and then we will see how XXS can kick in to mitigate the effects. So assume you have your attacker here, and the attacker crafted a malicious payload containing a script tag here, right there. And the victim is somehow lured to click this link. And then what the browser of the victim will do is just send an HTTP request to the vulnerable web server. And then the web server will respond. And in the response, there is the script content, also like this evil script content. And when the browser then renders the HTTP response, it will somehow come across this script content, and it will then request additional content from the evil domain here. So, in doing that, then the payload can be executed within the victim's browser. So, how can CSP now help us with that? So, CSP is a security header, and assume now that the vulnerable web page has a sane CSP header configured. Then that CSP header would be part of the HTTP response. And you can note at this point here that the malicious script payload will still be within the HTTP response as well. So what's the difference now is that when the user's browser tries to render the HTTP response and comes across this evil script, it checks it against the CSP policy, and only if it's allowed by the policy, it will send the additional GET request. And in our case, it's not allowed, so CSP mitigated this effect here. So it's actually a very nice mechanism, and in theory, it should work, right? But oftentimes, theory and practice don't really align. And we will now see how CSP evolved over time and whether or not it's really picked up in practice. So the content security was initially released in 2012, and it was created to restrict script content. So consider the snippet here of an HTML document. You can see that there is an advertisement script included, and that advertisement script in turn will programmatically add other scripts. So for example, from the companies that it will show to the user. And then you also have some other inline script that's just some meaningful inline content here. And what the user can then do, or like the developer can then do, is create an origin-based allow list. And you can also allow this inline script here using unsafe inline. And this unsafe inline expression does the trick here, but it's actually something you do not want, because an attacker can execute also inline script as well. So this is something we just don't want. So this is why in the next version of CSP, they added support for nonces. And by embedding a nonce as an attribute to a script tag, as you can see here in this snippet again, the developer is now able to allow inline scripts. However, if one of those allow listed scripts add another script programmatically, as is the case with our add script again, which is also very common in the wild, the script will not have a nonce and thus will not be executed. And so you might have some functionality loss there. And this in turn led to the CSP level 3 here, and this includes the strict dynamic directive. And again, you can nonce your script, and if you have also the strict dynamic directive in place, it will just basically say, okay, this nonce script here, it can programmatically add as many other scripts as it wants to, and we trust that. So as you can see, the CSP standard has evolved a lot over time, and it's been quite a journey already to adapt it more closely to the technical reality. So in addition to restricting script content, CSP can also restrict a plethora of other content types. And it can also be used to control framing behavior. It can be used to enforce secure network connections. So it has actually multiple use cases also. So next we will see how widely it's actually adopted and if people are actually able to use that correctly. So there is some previous work. It's also done by like Sebastian Roth. He's also an author of the paper I'm presenting right now. And what they did is they had this longitudinal analysis of 10,000 highly ranked online domains. And what they found then is that only a very small portion of those domains actually deploy a CSP. So that's something, yeah, it's maybe not so nice. And if you look then closer to what they actually do there, is that those that use the CSP oftentimes misconfigure it. And if I'm saying misconfigure it, I actually mean that they deploy such unsafe directives as, for example, unsafe eval or unsafe inline, or they whitelist complete schemas such as HTTP or HTTPS. And what they also found is that the deployment process of a CSP in and of itself can be very long and also very cumbersome. So we have this technical perspective now here, and it's quite well measured and also quite well researched. But why do all these effects actually occur? So this is something we wanted to look a bit closer at. And actually, if you think about it, we have this technical perspective covered, but actually we have been missing an important part about CSP, and that's the people that actually work with it. So what we did in this paper is we tried to incorporate the human perspective into the picture and looked at the different root causes these insecure practices we could observe in the wild actually have. Then we also looked at which different strategies developers adopted when they wanted to create a CSP and how well they actually understood the associated threat models and also what they thought about CSP, what's about CSP's capabilities. And last but not least, we also looked at their internal motivations to deploy the mechanism. So what we try to do is we try to generate some meaningful evidence, and we try to do that by considering the human as part of the technical system. Because you cannot just consider the technical system because you have all those people who interact with it. And if you want to understand like the complete landscape, you have to factor in the human beings. And we hope that with that reasoning, we can promote change, hopefully, but based on evidence that people give to us, so that developers tell us about, and not based on some assumptions that some expert might have. So in our CCS paper, it's actually a first step in the direction. I'm going to give you a brief overview over what we did methodology-wise. So we asked 12 web developers about their experiences during CSP development and what different things they came across while they tried to develop a CSP for their company in the wild. So we tried to cover those real-world issues with a semi-structured interview. But at the same time, we also wanted to have a more fine-grained, deep-down look at what technical things might go wrong. And this is why we incorporated a coding task where we prepared a little web application, and our participants then had to draft a CSP for that web application. And that just enables us to get a more deeper look into what the reasoning was, how people approach the problem, and also like, which technical intricacies might go wrong. We recorded everything, and then we transcribed the recorded data to text form. And what we got is very rich qualitative data. And if you have that, what you can do to evaluate it is go the way and do an open coding process. So in a nutshell, you can say that's just an approach you can take to extract the core themes and concepts and topics out of this qualitative data in a systematic way. And you try to do this like as unbiased as possible. I mean, Of course, the analysis is done by humans, so it will always be biased in some way, but you usually do it with 2 persons, so that's also what we did. And then you try to get a more unbiased view to the data set. And then what's extracted out of that helped us to find out more about the motivations, about the strategies, and about different factors that might block a secure or a sane adoption of a sane CSP. And yeah, I'm going to give you now a brief tour through our findings in terms of roadblocks. So consider your average web developer here. And usually web developers are human beings. So you have some roadblocks that are tied to that fact that you're a human. So you might have some knowledge gaps. You might have some conceptual issues with regard to threat modeling, for example. CSP itself is a very complex security mechanism, arguably the most complex security header. And because of that complexity, some issues, of course, arise. Some of our participants, they were just so used to built-in security features that they thought that they were not really responsible for crafting a CSP, but that is something that the framework should do for them. And then, of course, you have your occasional security as a secondary goal, which you can find oftentimes. And it's just because people have also other things to do. And as it's also such a time-intensive practice to craft a CSP, that can be delayed. So assume, nevertheless, this developer really wants to do a CSP. And the first thing that you probably will do is you will go online and just search for information sources. And what you will find there online can oftentimes be misleading. So for example, you have your obligatory Stack Overflow post that just tells you to use unsafe inline and be done with it. That's something that also prior work oftentimes finds. But maybe more interestingly is that there is in general the lack of a bigger picture. And what I mean by that is that you have that really intricate, detailed view on what all those different directives do. And of course you need that to deploy a policy. But in terms of how you strategically can approach this project of deploying a CSP for your application, that was oftentimes missing, and that was oftentimes causing a little bit of trouble. Then, of course, you have your application that you need to take care of. And the roadblocks you will run into there really much depend on the life cycle your application currently is in at the time that you decide that you need a CSP. So if you very early on decide that you need a CSP, you can just design your application to be CSP compliant. But if you have an already living and breathing application, as is oftentimes the case in the wild, then you somehow have to account for things like inline JavaScript, inline events, and also some legacy code that might be left somewhere. And accounting for that comes with a huge engineering effort oftentimes, because you, in most cases, at least need some refactoring to be done in order to make your application CSP compliant. Then also maintenance is a huge issue, because third-party libraries, for example, often change. That's what also found by prior work. And you have to somehow keep track of them in your CSP. And if you don't do that, then you will have breakage, and that's something you just constantly want to avoid. Then developers usually don't come alone, they come in teams. And if you have a huge company, you oftentimes also have different development teams. And that can also cause issues, because say the front-end team wants to include this new fancy library to do some trick, and just does that, that can cause breakage if the backend team is not properly informed about that, because it's in the responsibility of the backend team to take care of the security headers. So if you want to take care of that, you need a more streamlined approach there. You have to somehow connect the knowledge of both teams. And speaking about third-party libraries, that is really something that is causing huge issues for CSP deployment, because as I already told you with the strict dynamic thing, you have oftentimes, for example, advertisement providers, and they might programmatically add other scripts of which you cannot really keep track. So you need this strict dynamic directive, but at the same time, you often have libraries or services that are not in and of themselves CSP compliant. So they would require you to deploy an unsafe inline or unsafe eval directive. So that causes huge issues because they are not compatible with each other. So you have this technical problem, but at the same time, you have also a more, I would say, political or financial problem, because it might not be so easy for the company to just switch your advertisement provider, or you might be very dependent on some certain third-party service, for example, to share your content, and the Twitter share button is not CSP compliant, so it's like messing with your CSP and it's blocking it. And maybe what's also interesting about that is that the developer oftentimes people think developers are more or less in control of third parties, but that's not necessarily the case, because like those strategic decisions, so for example, which advertisement company we should work with, is not oftentimes not on them, so they can really not do anything about that. And then last but not least, of course, you have the browser. So the CSP lives within the browser, and you have to deal with all sorts of browser inconsistencies. So how they deal, for example, with certain properties. You have different browser console messages, so that can be more or less helpful for you if you try to debug your CSP in the browser console. You can have some false positive reports because of browser extensions doing weird stuff. And in general, those reports might not be very sufficient for you to debug your CSP. And I want to talk a little bit more in detail about this whole reporting feature and debugging feature for CSP on the next slide, because that's very interesting, I think, also for you. So say this is your application, it's cutekittenpics.org or something. And since your site is super popular, you have a lot of users with all kinds of different browsers, and those users have different extensions. So I have here a very colorful landscape of users and different configurations here. And say now you want to deploy a CSP for your application. Then you have essentially two options. So you can go with enforcement mode. And as the name says, enforcement mode will enforce your policy. And since the CSP runs in the browser and there might be inconsistencies, for example, in which directives the browser supports, or which CSP level, and how they handle certain properties, this can cause issues, and this will then also cause breakage. And then you have the second option, and that's called the report-only mode. And this will not enforce your CSP, but it will send a report whenever a violation occurs. And that's very interesting, I think, because in some sense, this is quite similar to fuzzing, because your users generate arbitrary input because they click on your application, they click on different things. And the users themselves are also arbitrarily configured in terms of which browsers they use and which plugins they have. And that then can generate huge amounts of reports. And interestingly, one of our participants, for example, quoted that they accidentally DDoSed their endpoint because they had a policy misconfiguration, which generated hundreds of errors per page. So you have this sheer amount of reports that you have to somehow deal with. But at the same time, you have the second problem, because you have to somehow sort through all those false positive reports and filter out the ones that are really relevant for you. So the ones that might be due to some misconfiguration, for example, or due to something that's just wrong on your site, or even there was a attack going on, something like that. Okay, so to sum that up, you saw that there's roadblocks everywhere, essentially. And they are really distributed across the ecosystem, so to say. And what I really want you to take home from this is that there is not that one thing that goes wrong with CSP, but that we have different aspects that fail simultaneously and that might depend on one another. And even if you were to fix, for example, the third parties here, then you still would have to deal with all the usability issues somehow. And moving forward, we actually really want to do that also. So we want to, like, what we did right now is we measured the status quo, so to say. Like, we made a picture of the landscape, and now we really also want to have to improve the status quo. So, for example, you want to remove roadblocks. We want to try to develop tooling that really meaningfully can help developers. We want to improve on the information sources that have proven to be difficult. And also, potentially, we want to guide design decisions with respect to security headers moving forward. And we want to do that in a bottom-up fashion. So putting the web developers in the center, in the focus. And what's really hard about these studies is like recruiting web developers. So I can tell you stories about that. It's really hard. And so I would be very happy if like there's some web developer listening right now, if you could just scan the QR code or just visit the link and just drop your contact information in our survey there, so that we maybe can contact you for future studies. That would be like a huge, huge help for us. Okay, so yeah, thank you very much. That was my talk, and I'm very happy to take questions now.
For that talk, and to our audience, if you are a web developer, please do consider taking part in these studies. They help us incredibly to figure out what's actually going on, and it's important for researchers to be able to get that view to improve systems. So if you can, do take part, please.